Top 25 Infrastructure Engineer Interview Questions and Answers. Infrastructure engineers play a vital role in designing, implementing, maintaining, and optimizing an organization's IT infrastructure. They ensure that servers, networks, storage systems, cloud environments, and security solutions operate efficiently and reliably. Employers look for candidates with strong technical expertise, problem-solving abilities, communication skills, and experience managing complex infrastructure environments. Whether you are a beginner entering the field or an experienced professional seeking career advancement, preparing for common infrastructure engineer interview questions can significantly improve your confidence and performance during the interview process. 1. What is the role of an infrastructure engineer? An infrastructure engineer is responsible for designing, implementing, managing, and maintaining an organization's IT infrastructure. This includes servers, networks, storage systems, cloud platforms, and security solutions. The primary goal is to ensure systems remain secure, reliable, scalable, and efficient. Infrastructure engineers also troubleshoot technical issues, perform upgrades, monitor performance, and support business operations. Their work helps maintain system availability while ensuring the organization's technology environment meets current and future operational requirements. 2. What are the key components of IT infrastructure? IT infrastructure consists of hardware, software, networking components, data centers, cloud services, storage systems, and security solutions. Hardware includes servers, computers, routers, and switches. Software includes operating systems and management tools. Networking connects devices and enables communication. Storage systems manage data, while security protects infrastructure from threats. Together, these components support business applications, communication, and operational processes. A well-designed infrastructure ensures reliability, scalability, performance, and business continuity across the organization. 3. What is virtualization? Virtualization is a technology that allows multiple virtual machines to run on a single physical server. Each virtual machine operates independently with its own operating system and applications. This approach improves resource utilization, reduces hardware costs, and simplifies infrastructure management. Popular virtualization platforms include VMware, Hyper-V, and KVM. Virtualization also enhances disaster recovery, scalability, and flexibility. Organizations use virtualization to optimize infrastructure performance while reducing operational and maintenance expenses across data center environments. 4. What is the difference between a physical server and a virtual server? A physical server is a dedicated hardware machine that runs operating systems and applications directly on its hardware components. A virtual server operates within a virtualized environment using shared physical resources managed by a hypervisor. Virtual servers offer greater flexibility, scalability, and resource efficiency compared to physical servers. Organizations can quickly create, modify, or remove virtual machines as needed. Physical servers may still be preferred for workloads requiring maximum performance or specialized hardware resources. 5. Explain the OSI model. The Open Systems Interconnection (OSI) model is a framework that explains how network communication occurs through 7 layers. These layers are physical, data link, network, transport, session, presentation, and application. Each layer performs specific functions and communicates with adjacent layers. The OSI model helps engineers understand networking concepts, troubleshoot communication issues, and design efficient network architectures. It provides a standardized approach for analyzing data transmission between devices across various network environments and technologies. 6. What is a VLAN? A virtual local area network, VLAN, is a logical segmentation of a network that groups devices regardless of physical location. VLANs improve network performance, security, and management by separating traffic into distinct broadcast domains. They reduce unnecessary network traffic and help isolate sensitive systems from other devices. Infrastructure engineers use VLANs to organize departments, applications, or security zones efficiently. VLAN implementation enhances network flexibility while simplifying administration and improving overall operational efficiency. 7. What is DNS and why is it important? The Domain Name System, DNS, translates human-readable domain names into IP addresses that computers use for communication. Without DNS, users would need to remember numerical IP addresses for websites and services. DNS improves usability, accessibility, and network functionality. It also supports load balancing, redundancy, and service discovery. Infrastructure engineers manage DNS configurations to ensure reliable connectivity and efficient communication between systems. Proper DNS management is essential for maintaining network stability and application availability. 8. What is DHCP? Dynamic Host Configuration Protocol (DHCP) automatically assigns IP addresses and network configuration settings to devices on a network. This eliminates the need for manual IP address assignment and reduces configuration errors. DHCP distributes important information such as subnet masks, default gateways, and DNS server addresses. Infrastructure engineers use DHCP to simplify network administration and improve scalability. Proper DHCP configuration ensures devices connect efficiently while maintaining organized and manageable network environments. 9. What is load balancing? Load balancing distributes network traffic or application requests across multiple servers to improve performance, reliability, and availability. By sharing workloads, load balancers prevent individual servers from becoming overloaded. This improves response times and reduces the risk of service outages. Infrastructure engineers use load balancing solutions in web applications, cloud environments, and enterprise systems. Effective load balancing supports scalability and business continuity by ensuring resources are utilized efficiently and traffic is managed appropriately. 10. What is RAID? RAID, or Redundant Array of Independent Disks, is a storage technology that combines multiple drives to improve performance, redundancy, or both. Different RAID levels offer varying benefits. For example, RAID 1 provides data mirroring, while RAID 5 combines fault tolerance and storage efficiency. Infrastructure engineers use RAID to protect critical data and ensure system availability. Selecting the appropriate RAID configuration depends on performance requirements, budget considerations, and organizational data protection needs. 11. What is disaster recovery? Disaster recovery refers to processes and strategies designed to restore systems, applications, and data after unexpected disruptions. These disruptions may result from hardware failures, cyber attacks, natural disasters, or human errors. Infrastructure engineers develop disaster recovery plans that include backups, redundancy, failover systems, and recovery procedures. Effective disaster recovery minimizes downtime and business impact. Organizations rely on disaster recovery strategies to maintain operational continuity and protect valuable information during emergencies. 12. What is high availability? High availability refers to designing systems that remain operational with minimal downtime. It involves implementing redundancy, failover mechanisms, clustering, and monitoring solutions to ensure continuous service availability. Infrastructure engineers build highly available environments to support critical business applications and services. High availability reduces service interruptions caused by hardware failures, software issues, or maintenance activities. Organizations depend on high availability architectures to maintain customer satisfaction, operational efficiency, and business continuity. 13. What is cloud computing? Cloud computing delivers computing resources such as servers, storage, networking, and software over the internet. It allows organizations to access scalable resources without maintaining extensive physical infrastructure. Cloud platforms offer flexibility, cost efficiency, and rapid deployment capabilities. Infrastructure engineers manage cloud environments, optimize resource utilization, and ensure security and compliance. Popular cloud service models include infrastructure as a service, platform as a service, and software as a service, each supporting different business requirements. 14. What is infrastructure as code, IAC? Infrastructure as code is the practice of managing and provisioning infrastructure using code instead of manual processes. Tools such as Terraform, Ansible, and CloudFormation automate infrastructure deployment and configuration. IAC improves consistency, scalability, and efficiency while reducing human errors. Infrastructure engineers use IAC to manage complex environments, implement version control, and accelerate deployment processes. This approach supports modern DevOps practices and enables reliable infrastructure management across cloud and on-premises environments. 15. What monitoring tools have you used? I have experience using infrastructure monitoring tools to track system performance, resource utilization, and service availability. Common monitoring solutions include Nagios, Zabbix, SolarWinds, PRTG, and Prometheus. These tools help identify potential issues before they impact users. Monitoring provides valuable insights into server health, network performance, and application behavior. Infrastructure engineers rely on monitoring systems to maintain operational stability, optimize performance, and support proactive troubleshooting and capacity planning efforts. 16. What steps would you take when troubleshooting a server outage? When troubleshooting a server outage, I first identify the scope and impact of the issue. I check monitoring tools, system logs, network connectivity, hardware status, and recent configuration changes. I gather information from users and stakeholders to understand symptoms. After identifying the root cause, I implement corrective actions and verify system functionality. Finally, I document the incident, communicate updates to relevant teams, and recommend preventative measures to reduce the likelihood of future outages. 17. How do you ensure infrastructure security? I ensure infrastructure security by implementing strong access controls, regular patch management, firewall configurations, antivirus solutions, and continuous monitoring. I follow security best practices such as the principle of least privilege, multi-factor authentication, and data encryption. Regular security audits and vulnerability assessments help identify potential risks. Employee awareness and incident response planning are also important. Maintaining security requires a proactive approach to protect systems, applications, and sensitive organizational data from evolving cyber threats. 18. What is the difference between TCP and UDP? TCP, or Transmission Control Protocol, is a connection-oriented protocol that ensures reliable data delivery through error checking, acknowledgements, and retransmissions. UDP, or User Datagram Protocol, is connectionless and focuses on speed rather than reliability. TCP is commonly used for web browsing, email, and file transfers, while UDP is preferred for streaming, gaming, and voice communications. Infrastructure engineers choose between TCP and UDP based on application requirements, balancing reliability, performance, and network efficiency. 19. Explain the importance of backups. Backups are essential for protecting organizational data from accidental deletion, hardware failures, cyber attacks, and natural disasters. Regular backups ensure that critical information can be restored quickly when unexpected incidents occur. Infrastructure engineers develop backup strategies that include scheduling, retention policies, offsite storage, and testing recovery procedures. Effective backup management supports business continuity, minimizes downtime, and reduces the risk of permanent data loss. A reliable backup solution is a fundamental component of disaster recovery planning. 20. What is network redundancy? Network redundancy involves deploying additional network components and communication paths to eliminate single points of failure. Redundant routers, switches, internet connections, and power supplies help maintain connectivity during hardware failures or maintenance activities. Infrastructure engineers implement redundancy to improve reliability and availability. If one component fails, another automatically takes over, minimizing downtime. Redundancy is particularly important in critical business environments, where continuous access to applications and services is essential for operational success. 21. How do you manage infrastructure capacity planning? Infrastructure capacity planning involves analyzing current resource utilization, forecasting future demands, and ensuring sufficient capacity to support growth. I monitor server performance, storage consumption, network traffic, and application workloads to identify trends. Based on this analysis, I recommend upgrades, scaling strategies, or resource optimization initiatives. Effective capacity planning prevents performance bottlenecks, reduces costs, and supports business objectives. It ensures that infrastructure resources remain aligned with organizational needs while maintaining operational efficiency. 22. What is Active Directory? Active Directory is a directory service developed by Microsoft that manages users, computers, groups, and network resources within an organization. It provides centralized authentication, authorization, and policy management. Infrastructure engineers use Active Directory to simplify administration, enforce security policies, and manage access permissions efficiently. Features such as group policy enable consistent configurations across multiple systems. Active Directory plays a critical role in enterprise environments by improving security, scalability, and user management capabilities. 23. How would you migrate infrastructure to the cloud? Cloud migration begins with assessing existing infrastructure, applications, dependencies, and business requirements. I create a migration strategy that includes planning, testing, security considerations, and risk management. Workloads are prioritized based on complexity and business impact. Data and applications are migrated using appropriate tools while minimizing downtime. After migration, performance and security are validated. Continuous monitoring and optimization ensure successful cloud adoption. Proper planning and communication are essential for a smooth and efficient migration process. 24. What is a firewall and why is it important? A firewall is a security device or software application that controls incoming and outgoing network traffic based on predefined security rules. It acts as a barrier between trusted and untrusted networks, helping prevent unauthorized access and cyber attacks. Infrastructure engineers configure firewalls to allow legitimate traffic while blocking malicious activity. Firewalls are critical components of network security because they help protect sensitive information, maintain compliance requirements, and reduce exposure to external threats and vulnerabilities. 25. How do you prioritize multiple infrastructure projects? I prioritize infrastructure projects by evaluating business impact, urgency, resource availability, risk levels, and organizational objectives. Critical projects affecting security, compliance, or business continuity receive immediate attention. I collaborate with stakeholders to understand priorities and establish realistic timelines. Project management tools help track progress and allocate resources effectively. Regular communication ensures alignment across teams. By balancing short-term needs with long-term goals, I ensure projects are completed efficiently while supporting organizational success and operational stability. Infrastructure engineers are essential for maintaining reliable, secure, and scalable technology environments that support business operations. Employers seek candidates who understand networking, servers, virtualization, cloud technologies, security, disaster recovery, and infrastructure automation. Successfully answering interview questions requires a combination of technical knowledge, practical experience, and problem-solving skills. By preparing thoroughly and demonstrating confidence, candidates can showcase their expertise and readiness for the role. Strong communication, continuous learning, and adaptability will help infrastructure engineers succeed in interviews and build rewarding long-term careers.